Hello friends, today's lecture on resolution of a force. Let us start with a definition of that. The replacement of a single force by a several component which will be equivalent in action to the given force is generally called a resolution of a force. That means whenever any force that is applicable on any body, and if you convert that force into different components with having a equivalent action, that process is generally known as a resolution of a force. In other way, if we see, so it is a process of finding out number of component of a force which will produce the same effect as a single force. That is also called a resolution of force. The meaning of that is, if any force is available on a body and if you replace that force with a different component of that particular force without changing the effect, whatever the effect generated by a earlier single force, so that you can say that that is the resolution of force or the force components. It is generally a reverse action of addition of component vectors or a force. So in earlier lecture we see that how to find out a resultant of force. So same way, this is a reverse process of that. From the force you can find out a component of the force, and the effect of resultant as well as the component, that will remain same. I think it is clear what is a resolution of a force. Now let us understand with some depth. Now resolution of a force can be done into two methods. One is orthogonal component and second one is non-orthogonal components. So when you resolve any force, that resolution is of two types, orthogonal or non-orthogonal. Let us start with first orthogonal components. So orthogonal components, we can say that when we resolve force in components and that component particularly make a 90-degree with each other, at that time that components are known as orthogonal components. So here, if this is R is the force, or you can say a resultant, and from that resultant if we find out two different component P and Q, that will produce a similar effect whatever the effect produced by a resultant R. So we can say that P and the Q are the component of that resultant force, but P and Q if make a 90-degree between each other, so we can say that this P and Q are the orthogonal components. If we know that the theta between one force and that component, so we can easily resolve that components like this. So if P is equal to R and the sine theta if we use, if you know this angle, so to find out this component we generally use a sine theta. So R sine theta, that will give the value of P, and if you want to find out component Q, theta is known and the theta is the angle between force and the component, so you can directly multiply R with the cos theta, so that will give you the value of Q component. Is it clear? I think. Now let us see a second one, that is a non-orthogonal component. So that component are not perpendicular to each other means that cannot make a 90 degree as we see in a orthogonal component. So this type of components are known as non-orthogonal components. So look at this force. This is the resultant or a force R, and if P and the Q are the component of that, and the angle between P and Q is more than 90, maybe that is less than 90 degree, so we can say that this P and Q are the component in non-orthogonal manner. Let us take one example to calculate orthogonal components. So here one force that is of 100 kilonewton, and we want to find out A and B. Those are the component of this 100 kilonewton, and the 100 kilonewton force that makes theta is equal to 30 degree, and that is with component A. Now if you want to resolve A, we know that theta is equal to 30 degree, so you can directly apply 100 cos 30, and the direction of that particular component, that is in positive x, so we can use a positive sign here. So the answer will be 86.60 kilonewton in this particular direction. Here if we want to find out a B, so 100 sin 30, because this angle is between the force and the component, and that we can say 90 degree minus 30 degree. So if you want to use here 100 cos, so you can use 90 minus 30, or you can directly use sin 30. So the answer will be 50 kilonewton in this upward direction. So this is the resolution of orthogonal components. Now let us see another example. So here the body on an incline is subjected to the vertical as well as horizontal forces, and we require to find out the component of each force along x and y axis parallel as well as perpendicular to the incline. Now here it is the case, this is a incline object, and on that incline object F1 and F2, two forces are acting, but we have to resolve that two forces into a component with respect to y and the x. That x is parallel to the slope and y is the perpendicular to the slope, and slope is given here, that is 4:3. So we require to resolve the component accordingly. So let us see how to resolve it. So here this is a given problem. Now first of all we take F1 1200 Newton, and we require to convert that into two components. So first one is this and second one is this. One is a parallel component, that is F1x, and another one is a perpendicular component, that is F1y. Now if we want to resolve it, we have to know the angle between this perfectly as well as between this. So for that we just solve this component resolution by some find out the angle, and then we require to solve it. Here we have second force, that is 400 Newton, and for that we have parallel component is F2x, so we require to resolve this component in this direction, and second component is F2y, that required to resolve in this particular direction. Now let us see how to resolve that force into a component at parallel and perpendicular axis. So for that we start with first 1200 Newton force. So before solution of a component, we just find out first theta angle. What is the theta angle available here? So here this is given tan theta is equal to 3/4. So the theta value that is come out 36.87 here. I think is it clear? Now with this theta we can say that this is the horizontal line, and with the incline this is also theta is equal to 36.87 degree, and between this 1200 Newton force and horizontal we have a complete 90 degree angle. So this angle would be 90 minus 36.87 degree. So we can write that this F1x force that we want to resolve, so we know this angle now. So that angle is 90 minus 36.87. So with this 1200 you can directly apply cos, and the direction of that particular force is in minus x, so we apply a minus sign over here. If we resolve it, that would be minus 720 Newton. Either you can use a sign or you can use a minus sign over here, so you can clearly see that what is the particular direction of a force component. Second is F1y. If we resolve F1y in this particular direction, so we require to know this angle. Now what is the value of this angle? If you find out this, you can usually apply a cos here, but here we know this angle, and this is perfectly a 90 degree angle, so you can directly apply a sine with this. So sine 90 minus 36.87 with 1200. Again a force is in minus y direction, that's why it is minus. So that is 960 Newton in this particular direction. So this is a resolution of component for force 1, that is 1200 Newton. Now let us see that how to resolve that another force components. So first of all, the parallel one is F2x and a perpendicular is F2y. So again we know this angle, that is theta is equal to 36.87 degree. So to resolve that F2x, we can directly apply cos. So F2x is equal to 400 cos 36.87. So directly in positive direction answer would be 320 Newton. F2y again we know this angle, so this would be a perfectly a 90. So this is 90 minus 36.87. So F2y is equal to minus 240 Newton. So this is a component resolution of F2 force 400 Newton. I think it is clear now. One more example if we take here, that is the determination of x and y component for this system of force. So here first F1 is a force, that is 300 Newton, and that makes a 30 degree angle with horizontal x. Second force is given, that is F2 390 Newton, that is make angle with some slope, and third force is F3, that is 400 Newton, that makes 40 degree with negative x direction. So for that the component of different forces is like this. So F1x, F1y, F2x, F2y, F3x, and F3y. Now if we know the angle between those forces and particular axis, so we can easily find out component of that by applying simply a cos and sine. So first of all we find out F1x here. So F1x is 300 cos 30, because that makes a cos 30 degree angle with x axis. So the answer would be 259.80 Newton. F1y, that is in minus direction, applying sine 30 here, that is minus 150 Newton. I think it is clear now. Again we go for the second. So first we find out theta, that is 67.38 degree. That theta is at this location. This is a value of theta. Apply again cos and sine. F2x, that is minus 150 Newton. F2y, that is 360 Newton. F3x, that is with 40 degree angle in minus x direction, so that is minus 400 cos 40. So answer would be minus 306.42 Newton. F3y, that is 257.12 Newton. So this is the component of this F3 force. So you can see that these are the final answers of different component for F1, F2 and F3 forces. Now let us take one more example, and here example says that the forces are acting at point O and required to find out that magnitude and the direction of force. But here something is written in terms of the axis, so we require to resolve that and draw a particular force system here. So for that it is given 500 kilonewton acting due north. So this is 500 kilonewton and acting north. If we take north as this, south, this is our west direction, and this is our east direction. 800 kilonewton acting southwest, so that is starting from the south and to the west, so that is in between exactly a 45 degree. 1000 kilonewton acting 30 degree east to south, so 1000, that is east to south 30 degree. And finally 300 kilonewton acting from the west, so that is applicable at this point like this. Now to resolve that, you can also resolve with using a table form. So here we take a 500 kilonewton force that is towards y direction, so the component Fx would be 0 and Fy is completely a 500 kilonewton. 300 kilonewton if we take, so that 300 kilonewton is completely to the positive x direction, so we have only one component, that is Fx, and the Fy component is completely 0. 800 if we take, so that makes a 45 degree, so you can resolve by applying a sine and cos here, so that would be minus 565.68. both are the same and both are in negative direction. 1000 you can take, so that makes a 30 degree, you can resolve with cos and sine. So these are the final answer for the component of this given four forces. So now this is all about resolution of a force.